Welcome back, ladies and gentlemen. In the previous video, we discussed about understanding spatial data science, where we started on the definition of spatial data science and later discussed the unique aspect of spatial data science. We also answered the question, why is spatial data science so important? One of the answers was spatial data science is not simply a geographic information system, neither is it a database management system, nor is data analytics or big data problem. It is rather the combination of all the disciplines. Kindly watch the previous video on understanding spatial data, part 1 to 4. The link is on the video description section. If you have not subscribed to my channel, kindly subscribe to my channel and then click on the notification bell to be notified whenever I upload a new video. Now let's move to today's topic. In this video, we would like to discuss about solution structures of spatial data science problems under the topic Spatial Data Science and Applications. The outline of today's lecture will include 4 disciplines for spatial data science and applications: open source software, spatial data science problems, spatial data versus spatial big data. Now let's move to 4 disciplines to have some expertise on in order to claim a role of spatial data scientists. They are, as you can see, Geographic Information System, that is the GIS, Spatial Database Management System, Spatial Data Analytics, Big Data System. Definitely, application domain knowledge will be a big plus, such as business, urban planning, transportation science, public health, disaster management, and any domain where spatial data are intensively used. Now, let's briefly review each discipline one by one. GIS stands for Geographic Information System. It can be defined as a system which collects, stores, and manages, queries, analyzes, visualizes spatial data. In a wider definition, a system which combines hardware, software, data, people, or organization and policy regarding spatial data. GIS can be considered as the limited version of CAD for spatial data production, database management system for data management, and data analysis tool. The most powerful aspect with GIS is that it is a geovisualization tool which is specifically designed for cartographic representations of spatial data. In other words, map making is well supported. There are quite few GIS softwares in commercial market as well as in open source software domain. These commercial or proprietary GIS softwares are ArcGIS. ArcGIS undisputedly the leading GIS software. Hexagon Geospatial, Map Info Professional, Global Mapper, Small World, and Bentley Map, as well as a Pitney Bow Map Info. On the other hand, there are also open source software in the industry such as Quantum GIS, Diver GIS, Geoda, GVSig, Map Window GIS, SAGAS, that is System for Automated Geoscientific Analysis, Environmental Benefits Mapping and Analysis Program, BEMAP. Among the open source software above, QGIS and DavaGIS are the most popular. Pros of using GIS is that it has a basic capability of handling GIS analysis and management of data. It can also cover to a certain degree most all the processes of spatial data science and applications. Spatial data production, spatial data management, basic query, geoprocessing, some advanced analysis, and geovisualization. It can do everything. On the other hand, GIS has limitation that it can handle almost all aspects of spatial data science only with limited capability. It has deep database management system functionality, but it does not support standard query language and generally designed only for single user, meaning that GIS does not support some concurrency control, some analytical power, but it's not fully fledged. Furthermore, generally no big data functionality is presented. Spatial Database Management System. What is spatial database? Database that stores spatial objects and also provides operations to manipulate spatial objects. What is spatial database management? Spatial database management system is a database which can store and query not only conventional data set of number and text, but also user-defined data types of spatial data, such as point and polygon of vector objects and images of raster objects. It became feasible after object relational database management was developed. Spatial database management softwares are basically object relational database management system with the spatial data of built-in data types and spatial query language. Examples include Oracle Spatial, an extension of market-leading database management system Oracle, PostGIS, which is an extension of PostgreSQL, and open source software Microsoft SQL. Some limited versions of spatial database management are Spatialite and ArcGIS. Spatial database management inherited all the database management system functionality. So removal of redundant and inconsistent data, concurrency control, backup, and recovery are supported. In other words, characteristics of ACID, which stands for atomicity, consistency, isolation, and durability, are given and supported. In addition to that, as the name goes, it has spatial data type and spatial operations and spatial query language. Spatial data indexing and spatial query optimization are supported as well. However, it also has some limitations. Spatial database management has only limited operations supported in query language, so that it cannot deal with high-end modeling and analytics of spatial data. A visualization is also a big limitation. At the same time, just like any other database management system, spatial database management has weaknesses of big data management, which is based on different paradigms. Now, data analytics. It can be defined as data analytics is the science of analyzing raw data to make conclusions about that information. The techniques and processes of data analytics have been automated into mechanical processes and algorithms that work over raw data for human consumption. Data analytics help a business optimize its performance. Generally, it takes a series of processes such as cleansing, selecting, transforming, modeling, and summarizing data. There are many data analytic tools for domain-specific or generic purpose. There are a variety of data analysis tools of commercial or open source. R is the most renowned data analytic tool in open source community, which has its own ecosystem in which any developer can build his or her own package for spatial data analytics. R is a programming language for statistical computing and graphics supported by the R core team and the R Foundation for Statistical Computing, created by statisticians Rose Hacker and Robert Gentleman. R is used among data miners and statisticians for data analysis and developing statistical software. 9. First released in 2006, NIME's analytics platform has quickly been adopted by open source community companies and software vendors who use it to create data science. The open and intuitive software makes understanding data easy. You can create visual workflows using the drag and drop graphical user interface. Model your analytical steps while controlling data flow and ensure your work is current. Rapid Mana are also popular open source solutions. Rapid Mana is a cloud-based suite of products that helps you create an integrated end-to-end analytics platform. The open source product offers a wide range of features, including automation, through which it loops and repeats tasks and can complete in database processing automatically. The software also offers real-time scoring, which lets you work with the third-party software to apply statistical models. It operationalizes pre-processing, cluster, predictive, and transformation models. Grafana is an open source data analytics platform that allows you to monitor and observe metrics across different apps and databases. You get alerts that notify you when specific events happen, along with real-time insight into external systems. The above are some of the most popular open source software for data analytics. In commercial arena, there are many of data analytics tools such as SAS, that is a business analytics. The high-grade text analytics capability of SAS-based business analytics software allow users to inspect and transform and organize text data into relevant information that analysts can't explore to discover meaningful insight. Statistical Package for the Social Sciences, SPSS, is a very powerful and popular business data analytic tool. The SPSS software platform offers advanced statistical analysis, a vast library of machine learning algorithms, text analysis, open source extensibility, integration with big data, and seamless deployment into applications. Tableau Big Data Analytics. Experts agree that Tableau Big Data Analytics is one of the best business analyst software, given its dynamic and cutting-edge capability for unstructured text analysis. Tableau Business Analytics platform, which includes robust and reliable statistical tools, empowers users to perform an in-depth analysis of social media networks and predict patterns based on current and historical data. If you want more freedom in data analytics, then you can also consider direct programming language with many data analysis libraries such as Python and Java, or computing environments such as MATLAB as well. Now let's move to pros of data analysis or pros of data analytics. Data analytic tools are generally easy to use, provide a platform to build your own analysis, integration potentials. Quite few open source solutions has big advantage with intuitive graphic user interface and simple script language. There are quite a few excellent tools in open source community. The cons of data analytics tools are limitation in spatial data analysis, lack of spatial data management, limited geo-visualization capabilities, domain-specific, and too many solutions. Now, let's move to big data systems. What is big data? Big data refers to the large, diverse sets of information that grow at ever-increasing rates. It encompasses the volume of information, the velocity or speed at which it is created and collected, and the variety or scope of the data points being covered. Big data often comes from data mining and arrives in multiple formats. In the past, high-performance computing generally meant distributed system of task parallelism, meaning that competition jobs are distributed to each node. In the era of big data, data distribution as well as computation job distributions are required. The concept and programming model is called the MapReduce. Hadoop is an open source software with file system named Hadoop Distributed File System HDFS, which is an implementation of programming model of MapReduce. Hadoop has only limited capability of supporting distributed storage and computation, and even no support for accessing or updating individual data. Hadoop ecosystem is a platform or suite which provides various services to solve the big data problems. It includes Apache projects and various commercial tools and solutions. There are four major elements of Hadoop: HDFS, MapReduce, Yen, and Hadoop Common. Most of the tools or solutions are used to supplement or support these major elements. All these tools work collectively to provide services such as absorption, analysis, storage, and maintenance of data. The following are the components that collectively form a Hadoop ecosystem. HDFS, Hadoop Distributed File System. HDFS is the primary or major component of Hadoop ecosystem and is responsible for storing large data sets of structured or unstructured data across various nodes and thereby maintaining the metadata in the form of long files. HDFS consists of two core components such as name node and data node. Yen, yet another resource navigator, as the name implies. Yen is one who helps to manage the resources across the clusters. In short, it performs scheduling and resource allocation for the Hadoop system. It consists of three major components such as resource manager, nodes manager, and application manager. MapReduce, programming-based data processing by making the use of distributed and parallel algorithms. MapReduce makes it possible to carry over the processing logic and has to write applications which transform big data sets into manageable ones. Spark, in-memory data processing, is a platform that handles all the process consumptive tasks like batch processing, interactive or iterative real-time processing, graph conversion, and visualization. It consumes in-memory resources, hence that's being faster than the prior in terms of optimization. Spark is best suited for real-time data, whereas Hadoop is best suited for structured data or batch processing. Hence, both are used in most of the companies interchangeably. Pig. Pig was basically developed by Yahoo, which works on a pig Latin language, which is query-based language similar to SQL. It is a platform for structuring the data flow, processing and analyzing huge data sets. Pick does the work of executing commands, and in the background, all the activities of MapReduce are taken care of. After the processing, B stores the result in HDFS. Pick Latin language is especially designed for this framework, which runs on Pick runtime. Just the way Java runs on the jvm.pig helps Java. Just the way Java runs on the JVM, Pig helps to achieve ease of programming and optimization, and hence is a major segment of Hadoop ecosystem. Hive, query-based processing of data services. With the help of SQL methodology and interface, Hive performs reading and writing of large data sets. However, its query language is called HQL. Hive query language is highly scalable as it allows real-time processing and batch processing both. Also, all the SQL data types are supported by Hive, thus making the query processing easier. Similar to the query processing framework, Hive 2 comes with two components, JDBC drivers and Hive command line. JDBC along with ODBC drivers work on establishing the data storage permissions and connection, whereas Hive command line helps in the processing of queries. HBase, NoSQL database. It is a NoSQL database which supports all kinds of data and thus capable of handling anything of Hadoop database. It provides capabilities of Google Big Table, thus able to work on big data sets effectively. At times where we need to search or retrieve the occurrence of something small in a huge database, the request must be processed within a short, quick span of time. At such time, HBase comes handy as it gives us the tolerant way of storing limited data. Mahad, Spark MLRB. Machine learning algorithm libraries. Mahad allows machine learnability to a system or application. Machine learning, as the name suggests, helps the system to develop itself based on some pattern, user or environmental interaction, or on the basis of algorithm. Solar, hallucination, and indexing. These are the two services that perform the task of searching and indexing with the help of some Java libraries, and is based on Java, which allows spell check mechanism as well. However, Lucene is driven by SOA. Zookeeper. Managing cluster. There was a huge issue of management of coordination and synchronization among the resources or components of Hadoop, which resulted in inconsistency. Often, Zookeeper overcame all the problems by performing synchronization in component based on communication, grouping, and maintenance. OOS, job scheduling. OOS simply performs the task of scheduler, that's scheduling jobs and binding them together as a single unit. There's two kinds of jobs, OOS workflow and OOS coordinator jobs. OOS workflow is the jobs that need to be executed in a sequentially or ordered manner, whereas OOS coordinator jobs are those that are triggered when some data or external stimulus is given to it. Likewise, additional needs brought a new solution to Hadoop ecosystem and keep growing and changing. Hadoop framework presents capability of big data management and analytics, which used to be impossible with existing technology for big data processing. It can present both scalability and resilience for data management, flexibility and speed of data analytics. Additionally, they are all open source solutions. They are all big advantage of using big data systems. There are also disadvantages of big data system. The most critical issue of the data system for us is that it's not designed for spatial data. Hadoop is a shared nothing structure, so that it's good for only independent computing with big data. Any advanced spatial analysis can hardly be implemented in Hadoop framework. Certainly, no capability of spatial and visualization. Hadoop shared nothing structured, good for only independent simple parallel computing with big data. So far, we have briefly reviewed the 4 different disciplines to understand in order to claim a role of spatial data scientists. They are GIS, spatial database management, data analytics, and big data system. It is obvious that each discipline has pros and cons, advantages and disadvantages, and they need each other. Throughout this course, you will learn each discipline from basic to advanced. Alright, this is the end of the lecture. If you've not subscribed to my channel, kindly subscribe to my channel, like, share, and comment.